Good afternoon and welcome to this presentation about VMware Tanzu Observability. My name is Lutz Lange. I'm a solution engineer with VMware in the Modern Application Platform Business Unit. This session is part of the Tanzu Up Close event, and you've seen a lot of presentations and demonstrations already today. This session is not different, it's similar. We first need to lay some kind of groundwork and talk about what observability is and why you need that. And then I'll show you what this looks like and how this can be used to look into the whole stack of your applications and the infrastructure. So why observability? What is observability? Basically, observability is a characteristic of a complex system that allows you to find out what is going on inside, to see what's going on inside. So it is something that you need to design for. Earlier, this has been called monitoring, and the easiest and oldest approaches to do monitoring with IT systems is that you get the developers to put in statements into their code that outputs text. And you get these strings on the command line when you run an application or you put it into a file, and we call these things logs. But if your estate grows and there's many running components on physical servers and virtual servers, you have these log files lying around, it becomes quite difficult to analyze what is going on. This is a situation where tools like Splunk come in place that allow you to aggregate the dispersed log files into one central location and analyze that. Elasticsearch is another tool that is widely used for this purpose and is open source. With newer architectures like containers and microservices, another mode of monitoring came along, and this is what we call metrics. Metrics allow you to gather counters for transactions, for how much memory was used, how much CPU was used. It's put and collected into a database, and then tools are used to allow you to look at this data. And often this is done by Prometheus and Grafana today. So think about observability as a new kind of monitoring, a monitoring 2.0, if you will, that allows you to have a wealth of information that you can dig into and find out what is going on, what is going wrong, look for anomalous behavior and correlate different measurements with each other to find out outliers, for example. Observability is also part of a bigger movement in IT in general called DevOps, DevSecOps, that is about stepping back from the details and worries of one team and tries to look at the big picture of how IT can help bring the business forward. What the big picture is important here. And observability helps you to keep the big picture visible and soften the effect of the borders between the different teams. So while it is easy to build monitoring tools for known static systems, things become a lot more complex if you're using distributed microservice-based applications that run in a wide variety of infrastructures. So you could have an application that has a front end in AWS and a back end that runs on-prem. And in these situations, it is hard to reason about errors and misbehaviors, and you quickly end up with these Zoom war rooms nowadays, right? So where the specialists of all the teams come in and try to reason about what is going on, what is going wrong, and try to point at somebody else quickly to say, well, can't be with me, the error. This is something that we would like to try to avoid and make easier. So digital business and cloud native apps require a different approach to monitoring, to observability. And when you are in a world where we do not want to build monoliths, or where we go and break up monoliths into microservices, we do shift the complexity. The complexity of the monolith does not go away. It moves into how the different microservices are talking to each other. The stacks do become higher. There is more abstraction mechanisms in. And then we have different infrastructure. So there's many points of failures that we do have in these complex systems. But we still need a way to be quick when we troubleshoot. And it does not help that all different teams are using different tools that silo the data. This brings us back into this war room situation and it's kind of difficult. Let's look at what different tools are used in the stack today. And down on the infrastructure side, where there's compute, storage, and networking, even internet access and power, there's mostly vendor-specific tooling. If you're using virtualization, and you're using our virtualization, then you will have a vCenter or maybe a vRealize operations tooling that allows you to see what's going on in your virtualized infrastructure. It allows you for planning, capacity planning, and so on. On the level above, we are moving to the world of containers, to the world of Kubernetes, Cloud Foundry. This is dynamic resources that move around a lot. This is the realm where metrics become important, and Prometheus is one tool to gather this kind of information. On top of that, we have the realm where the classic APM tools, application performance management tools, can be found. This is the application domain, where developers write application code, instrument application code, where they make use of certain application frameworks and platforms. And metrics and traces are the components that we gather from these stacks. For the traces, developers need to usually write code and put that into their applications. And then they can see how calls are traveling through the stack. And we'll see that in a demonstration later on as well. There is this thing called user metrics, some APM tools called real user monitoring. And this is about seeing what happens between the browser and the server, so that we can get a feeling and measurements for how the application feels at the end user side, because sometimes the problems might lie in the network connection, in the last mile, if you will. For business metrics and KPIs, the golden grail for the business to see how certain issues impact the business. You will need to design for that usually and put specific parts, specific instrumentation into the application to be able to measure this. But having all this in one place is a good idea. And Tanzu Observability can help you here. While all these different tools are very useful and good and do their work very well, they are specialized and they silo the data. And we can help you here by using Tanzu Observability that can connect to all these different tools and layers in your stack and pull all the data into one SaaS-based tool that allows you then to build dashboards, smart alerts, and help you solve your problems. So we can help with the developer velocity, make it quicker for developers to find out what goes on in their application, but also help on the operations side with the identification of root causes. This is the Tanzu Portfolio, and you have seen this slide before, I want to quickly show you where we play a role with Tanzu Observability in this stack, and we'll find Tanzu Observability in the management section. There is a build section as well, and the goal of the build section is to make it easier and quicker for developers to work. So developer speed up is what we have in mind here, and we do have the Spring framework in there, and the Tanzu build service that allows you to quickly and consistently build images from your source code. We do have the run section, and this is where you find our Tanzu Kubernetes grid distribution, which is the basis for these new dynamic workloads. We did talk quite a bit about the service mesh today in the other sessions, which is an extension of the upstream Istio project, and makes a lot of sense if you're working with microservices a lot. The Tanzu Mission Control allows you to manage multiple clusters with one interface, and integrates into the Tanzu Observability and service mesh as well. So the Tanzu Observability tooling is part of the Tanzu Portfolio. That means there are integrations, and it's a good idea to use it with that, but it is not tied to the Tanzu Portfolio. You can use our Tanzu Observability with almost anything that has an API, and we have lots of integrations. I'll talk to you about that in a second. So it spans much further than just our portfolio. Quickly want to mention our VMware Tanzu Labs approach. This is a practice that comes from the pivotal time, and we help you and help our customers developing software and platforms the cloud-native way. And our goal there is to transfer knowledge. It's not body leasing, but we do have specific methodologies that we teach you in these engagements so that you can be self-sufficient and scale your cloud-native journey yourself. So back to Tanzu Observability. How does this work? Tanzu Observability has different components, and one of the main and important components is the real-time data ingestion. So we've seen the whole stack in the last slide, and we do have the different elements here again, from the applications to the infrastructure down, be it containers, cloud components, or serverless applications or microservices. We can ingest data in real time, and we've tested that with up to 10 million points per second. And we can ingest metrics, histograms, traces, and even span logs. So span logs is when things go wrong, you want to find out why they go wrong. And this is a capability for us to gather stack traces and error messages. And we put all that into our SaaS-based solution so that you can have alerts. You can use this to visualize things in a very time-critical, time-sensical matter, so that you have actionable information at your hands quickly. You can use it to troubleshoot and basically display this information and provide this information for all the different teams in your organization. And this is just a standard audience that we have here, the infrastructure, the SRE people, developers. There might be database specialists or people that need to see only one certain application from the whole stack. But they can all look at the same data, and that is data that is recent, and it makes it possible to reason about what's going on in a very productive and quick way. So how does this look like in a classical scenario, we do have the different teams here again from the infrastructure ops, and they might have a vRealize operations suite that they're using to see the virtualization stack and the physical infrastructure. There might be a DevOps platform ops team, and they might be using Ops Manager in PCF, and an app dev team that has some kind of APM solution. And if things happen in this stack, we do have this siloed data situation, right? Every tool is specialized, but displays the data in a certain way that is different from the other tool. And this is a situation that we want to help with. How do we do that? We do it through our integrations. We have over 220 out-of-the-box integrations, be it to the public clouds, for the hypervisors or operating systems, for data stores, to the containers, of course, web technologies, alert notification things, or with other APM tools, even like a New Relic. Most of our integrations are built on a very lightweight agent that's called Telegraph, and this is used a lot to ingest data. But as I've said before, everything that has an API or a log file can be ingested into Tanzu Observability. So what does it look like with Tanzu Observability? We can then use Tanzu Observability and our integrations to collect data from the whole stack. We can use it to visualize this data in any view we want to. For example, one view for the whole stack, and I'll show you this use case in the demonstration shortly. The data then gets normalized so that we can compare the different data points with each other and correlate issues that we are seeing in the stack to make sense of what is going wrong or going on in my infrastructure or application. This helps me a lot by in identifying root causes, and I can go even deeper and correlate certain metrics where I find an issue with each other. And this is something that we'll see in the demo as well. So, with Tanzu Observability, we do have a single platform for metrics, for histograms, for traces. We've tested it with even 10,000 or 10 million data points per second ingesting data. So it is quite scalable. We do have integrations into all the popular frameworks like Java, Spring, Python, and Go. And while traditional APM solutions require bulky resource-hungry agents, we can do a lot with the Tanzu Observability SDK that has negligible impact. If you're already using Open Tracing or Open Sensors, this is not a problem. We can connect that to Tanzu Observability. There is a Wavefront query language that is very advanced and powerful to query all the data that is in Tanzu Observability. But you do not have to use Wavefront query language if you don't want to. A lot of companies today are using Prometheus tooling, so there is a PromQL knowledge and capability in the company already. This is something that you can make use of and that you can retain and use that to create alerts and build dashboards even. It's only for the more advanced things in Tanzu Observability that you need the Wavefront query language. So the PromQL support is an easy way for onboarding. And with that, we are close to the demonstration. Let me quickly give you an overview of what I want to show you. So we'll take a look at the different integrations. We'll take a look at the charts and dashboards. You'll see an alert as well. And then we'll try to triage a production issue, look at how we can bring in data from the applications as well, and I'll look at the service view and the application discovery. Okay, switching to the demonstration. So this is the Tanzu Observability UI interface of our SaaS-based solution. I've said that we do have over 220 integrations, and we have a featured section here where you can find the public clouds like AWS, the Google Cloud Platform, Azure. There's Kubernetes. We'll spend a little bit more time on that. Cloud Foundry, integrations into operating systems like Linux, Windows, Mac, vSphere integration, of course. There's web technologies like Tomcat, like Nginx, for example. We do have big data integrations, lots and lots of public cloud integrations. There is data store integrations, MySQL, Postgres, for example, Redis. We do have messaging and monitoring tools. For example, Dynatrace, Datadog, and where is it? New Relic. Why would you want to integrate with one of these? So while these tools do cover similar tasks like Tanzu Observability, all of these tools work with data rollups, for example. So what is that? The data rollup is you get raw data in, but after a certain time you start to aggregate the data and only keep the summaries. We don't do that in Tanzu Observability. This is one of the major differences with other tools in the market. We do keep the raw data for 18 months. This allows you to do seasonal analysis at the end of the month or at the end of the year and look at stuff like Black Friday events or similar things. If you want to plan for something, and you can see all the details still there. This is one use case that a lot of customers of ours are doing. Operating system integrations. I don't want to go down to all the stuff here, but let's go back up and look at Kubernetes. So for Kubernetes, if you want to set up a Kubernetes integration, you go to the setup, then further down, click on the add integration button. And then you have a choice. So you can install it in a Tanzu cluster, in a general Kubernetes cluster, or in OpenShift. OpenShift is a bit special. Always, I'll look at Tanzu cluster integration here. And if you have Helm, you can use Helm to install our Tanzu Observability. You add the repository and then you update the repository. You can put your cluster name here. And then the installation command down here changes a bit. There's now my cluster name in. This is basically a kubectl that creates a namespace and a Helm install command. We do have a few parameters here. That is the Wavefront SaaS URL. This is a demo environment that resides in the US currently. We're just building up a Tanzu Observability SaaS instance in the German AWS cloud. So there will be one available in Europe quite shortly. And then there is a token in. This token is account specific and allows us to identify where things are coming from. If you don't have Helm, there is the option to bring out the components manually, and we'll look at that. So there is a Wavefront Proxy. If I look at the manual steps, the Wavefront Proxy is quite common way to architect the how we build this because through the proxy you have full control of what data goes out and how much data goes out to the SaaS backend. The solution is priced by points per second. So you should only send what you need to the SaaS backend. You also, as you are paying for this as well, and we're storing it for 18 months. This is your way to control it. You can configure this in the Wavefront Proxy. The second component is the Wavefront Collector. The Wavefront Collector for Kubernetes then connects to the Kubernetes API and gets all the details out about what's going on in the Kubernetes, what you want to see. And this brings me to the next step. This is the dashboards. For all the integrations, for all the over 220 integrations that we have, we do bring pre-built, pre-configured dashboards already, where you have a lot of information in that you usually want to see. This is what we start with here in the demo. Let's take a look at the Kubernetes summary. So this shows us all the different Kubernetes information that we have in here. It's in the whole backend that I have access to. And there is 13 clusters, 58 nodes, over 1,000 pods, 1,300 containers. We sorted this by cluster, node, pod, and container level metrics. And after the summary, we do have these top K charts. There is a special chart here, which is of interest, and this gives you the points sent. So this is points per second sent per cluster. And I can see that the EKS Wavefront Dev2 cluster did send 760,000 points per second. So there is quite a lot of metrics that are coming from this cluster. And if I switch to nodes per cluster, I can see I have 15 nodes in that cluster. So it leads the other top K charts here as well. 219 pods and 222 containers. If I scroll a bit further down, we do have CPU metrics. We do have memory averages. And on the bottom here in this dashboard, we do have kind of a health information, like how many pods failed, how many pods are pending, containers waiting, total number of restarts. This kind of information is quite helpful for judging health. But let's go to the pod level. I do have a cluster here, the carrot cluster that I want to show for this. So you can basically slice and dice this information, right? Also of interest, all the information that we're looking at here is time-spaced information. This is like a time explorer. We're looking here at the last 2 hours, and I could quickly set this to some other time frame, and I'm quite flexible with that. And there is a live mode that refreshes the dashboards every 30 seconds. What we get in the Kubernetes pod dashboard is a pod view where we can see CPU usage. Oh, I didn't want to click there. CPU usage, and the pods aren't doing much here. I could change that to memory or restarts. But more interesting is the group by feature, and I could group it by node name, and I can see which pods run on which node. I could group it by namespace name, and I could see how many pods are running on which namespace. So one of the namespaces here is the TakuCut namespace. This is where we have deployed an example application, an application where you can buy shirts in. And we'll see this application later on again. We do have a summary about what's going on with the pods, again, how many we have, what's the CPU usage and things like that. Then we do have more detailed information available. These line charts, and if I hover above these line charts, I do get a lot of more detailed information about the source, where this is coming from, what labels are different labels that we gather for the different workloads, the pod name, namespace name, of course, and the node name, the app label we have in here, and how many cores were consumed, for example. And one thing that I can do here is, if I see something that is of interest, like we do have certain spikes in here, we can zoom in. I just hold my mouse button and zoom in to this time frame. What I just did is I only zoomed in for this one chart. If this is something that is of interest, so there is the yellow line that we see here, and this is the packaging green pod that runs in the TacoCut application. If that is of interest and I want to see what's happening at the same time on the other charts, I can synchronize the time. So now the time changed and all the charts are showing the same time frame, and I can further analyze here what's going on and what happens. So while these things are interesting and helpful, these are built-in dashboards. What I want to show you next is a full stack dashboard. And this is what we have here. So in the slides before, I said, well, it's not a good idea if you have everything separated and all the special tools. It is difficult to reason about what's happening in your environment and in your applications. This is just that use case. So what we've built here is one dashboard that has everything that is of relevance to an application. This is for the TacoCut application that is running in a corrupt Kubernetes cluster. There is a business view in. We have built the application in a way that we can get KPIs. We do have a user experience section that is filled in by values that come from using Catchpoint. So it's a third-party integration. Then there is a stack overview, Kubernetes level, operating system metrics, VMs, ESX, even down to the hardware. Let's take a look. So for the last hours, we can see that we have 73.74% successful delivery rate. We made about 60K in sales, but also 21 in losses. So there's something that is going wrong here. Successful transaction rate is not that high. We do have 111 failed transactions in the last 2 hours. This might be something we need to evaluate. There is actually a list of failed services, and the shopping green is the service in the last 2 hours that had the most failures, and we will analyze the failures as well. But let's scroll further down for the whole stack view. There is our user experience testing. We did have 19 requests, and these red dots, by the way, are alerts. Pod CPU usage deviance. We'll talk about alerts in one of the next examples as well again. There is the stack overview, where there's interesting information from different layers of the stack, like containers, VMs, content load time. It looks like Istanbul is currently leading with the delay in reaching the site. So 19 seconds for loading this is a bit long. We can see alerts fired here as well, which is interesting. And there is something about a virtual machine CPU higher than the weekly average. in. We do have the Kubernetes layer information down here, very detailed stuff about port, memory, CPU rates, even network related stuff. Information from the operating system layer, from the VM layer, DSX layer, and we even see CPU temperature, so hardware information or information about network switches. So a full stack view that helps you to dig into what's going on with your application. We have a similar dashboard that we've built for a customer a while back, and I want to show you this next. And this is also full stack, as you can see here. And this is with a few application servers. These application servers are doing transactions, and we do have one of the KPIs up here that's transactions per second. An issue that we can see here in this time frame is that suddenly the number of transactions drop, and we raise an alert for that. We can configure the alerts and be quite specific about what is important to you. We come with a few built-in alerts already, and this is done through levels and time. So this is in a certain time frame, there is a quick drop, and that is what starts an alert. An alert has a start and has an end. And we now want to investigate what is the reason for this alert. One thing that we could do is we could ask us, how does this impact our customers? Is this only specific, or is it all? And when I switch the dimension here to customers, I can see it does impact all my customers. So if it does impact all my customers, is this related to all my application instances or just to a specific one? And we can see here it is a specific one. If I click on the metric that is dropping, I can see this is the application server number 5. So I do select application server number 5 now, and this gives me all the metrics from application server number 5 down here. These are a lot of metrics, and it is still a bit of a needle in a haystack to find out what is the cause. Tanzu Observability brings with it a function that helps you to see the specific metrics that correlate with the needle that we found on the other side in the KPI transaction per second for application server number 5. So I correlate that. I see now only the directly or indirectly correlating metrics in this chart, and this makes diagnosing the issue a lot easier. And I can now see that there is the free memory, the transaction counter, the garbage counter, and application log errors that are directly or indirectly connected to the dropping transactions, and this is an issue with memory, of course. So I have to look at the memory part. With that, let's switch to the other side of the house and look at what we can get from the traces, from the instrumentation in the applications. And this is the TacoCat application, and an application view that we built, an application map. And we can see that in this time frame that we're looking at, can also go to the last 2 hours. Let's look at that. There are errors, and we do have a color coding here. So the shopping service has more than 10% errors. It's instrumented with open tracing. It's a Java application with drop wizard in and a Jersey server. And where are these errors coming from? So they are coming from other components, and they're adding up here. So the payment service is involved, styling service is involved, and delivery service is involved. Let's maybe take a closer look at the delivery service. So all the services do have their own pre-built dashboards, And in this case, we do have the delivery service and summaries about how many requests per second, how many errors, how long service calls take in the 95th percentile, and then how this is plotted over the time that I'm looking at. There's top requests, failed requests as well, and slowest requests, and how these are the latency is distributed. And we do see metrics from the different technologies, application technologies used in the stack here as well. So there's something from the Jersey server, from the JVM, and if I do see an issue in here or want somebody else to look at this, there is a feature where I can just get a link here and copy that link, send it to a colleague and have him investigate, and you will see exactly what I'm seeing here. I want to now further investigate what it is with my calls here, and I'm interested in the top failed request. There is a delivery controller dispatch call that has a lot of errors. Let's investigate that. And we can now see that I do have the filter here for the taco card delivery controller dispatch call, and all the traces that are shown here do have this call in it. And these have different durations. It's all erroneous calls with a different count of errors. You can see in what percentile the traces fall, and let's investigate one of them. You do get a trace service map for all the traces that lists all the involved services. These are the components that we have spans for. You see an exclamation mark where we have found errors. You can click on these services and see the service summary again. These are the same metrics that we had on the last page, which tell you how many requests per minute, how many errors, and how long the calls took. If you look a bit further down, you can see here that we have details on all of these. I click on one of the calls, I can open the details for this call or span, and there are tags that we do collect, for example. It's a from production server, it's a HTTP post request, and we can also see that this has an error code, an HTTP status error code 500. So this is obviously the call that was initiated and got back with an error, but we do have a lot more details, and I want to scroll down a bit, go to the other components and see we have an error on the delivery service as well. This was what I was looking for. It's also visible up here. Let's look into that. So again, we can see all the tags, the span ID, and span ID is up here as well under the IDs, span ID, trace ID, parent ID. This is used to stitch the different spans together into one trace. But we do have something here that we didn't have in the other call. In this case, it was a call that had errors, and we attached the span log as well. And the span log gives us information about what went wrong here. So basically, the delivery service had an out-of-memory error. This is something that I can give back to the teams that are working with the service, and they can make adjustments. Might be a buffer overflow or something like that. It might be something in the environment, but you can now investigate. And I could do this with all the other errors that we've seen, or the other services that we've seen in the application map here. So this was the delivery service, but I could do this with the payment service, with the styling service, and try to eliminate all the errors that I see. So basically this was the big overview that I wanted to give you today about what observability is, and how we can use Tanzu Observability to gather information from the whole stack, be it the application layer, be it the infrastructure, or be it other data sources, that allows you to build these big dashboards and allows you to find out what goes wrong where very quickly and make you more productive. If you're interested in using or testing Tanzu Observability, we do have. If you're interested in testing Tanzu Observability, we do have a free trial available. Just go to our website, tanzu.vmware.com/observability, and then you can start your free trial here. And all you need to do is fill out the details, and we'll get back to you and give you access to the platform. Then it's up to you to just deploy the collector if you're using a Kubernetes environment and get started with Tanzu Observability. Thank you for your attention today, and I hope to see you soon.